Hello everyone and welcome to today's webinar. My name is Philip Radukic and I'm a product manager and senior consultant here at CX Experts, and as such responsible for the UPV web services, browser-based viewing and associated technologies. Today we're continuing our webinar series concentrating on various real-life use cases. These use cases will show some examples on how the UPV ecosystem can be implemented to make processes run more smoothly, how to save time and effort, and basically utilize the various features of UPV at its best. So today's part 9 of the series will be covering a topic relevant basically to all existing assets. So be it for owners and operators or for engineering partners, and that is keeping the model up to date. As always, this session will be recorded and we will provide you the link to the recording subsequently by email. At any time through the webinar, feel free to use the questions panel and state your questions, and I will try to answer as many as possible after the live demo. Okay, then let's start right away with today's agenda. So we'll have a look at challenges in keeping models up to date and what this means. So the live demo will cover the challenge of outdated documentation, the challenge of temporary obstacles, what this means, I'll come back to that in the introduction. The challenge of new elements in construction, what this means also, we'll have a look at it in the next step, and major changes in limited area. So these are all challenges that you face basically in a plant, and it's hard to keep the as-is status, which is even more current than the as-built status, updated. What is actually meant by as-is management of a digital twin? When a digital twin is recently created, everything should be according not only to as-built, but also to the as-is status. But unfortunately, as most of you will know from day-to-day business, this does not stay this way. So there's always some minor changes, some additional obstacles or objects placed temporarily somewhere, or temporary measures blocking the way that are not shown in the model, which is basically being a snapshot of a certain point in time. So sometimes, for example, minor pipelines are added. A valve is replaced or similar. The hand wheel might look a bit different. All of this leads to the model not being up to date anymore. And over time, a digital twin becomes rather a, excuse the pun, a digital sibling, or a, in the end, digital far relative. So today we'll have a look at various tools and features of UPV, which you can use to easily keep the model up to date on different detailing levels. So the challenges are, well, documentation has changed, is constantly changing. This temporary obstacles, what does this mean in detail? So this can mean a scaffolding being somewhere, so a certain passageway is not passable anymore. Or there might be an IBC container blocking the way for a forklift. There could be certain tools standing in the way, or it could be basically a blocked area for a crane or a bundle puller or similar. New elements added. So very often I experience that in my day-to-day life as a piping engineer on site before I joined CX Experts, that you actually get to the site and you have your documentation on you, you have the PIDs, you have drawings, layout drawings, and suddenly you see some pipelines that actually haven't been there in the plants. Why? Because sometimes maintenance and operations just needed to add a certain additional line or bypass or something that has not been, or Well, it has been documented, but it hasn't made its way into the official model and document management systems. So keeping this up to date is actually the biggest challenge when talking about digital twins. But this can also affect major changes in an area. So what does this mean? That basically a part of your asset, of your plant, of your building has been rebuilt or changed so much that the model should be redone, especially when we're talking about laser scans. Until now, it would mean you would have to repeat the whole laser scan thing just to have that single area revisualized as a point cloud, or in this case, a mesh. What are the risks? Well, if the documentation has changed, you're working with outdated documents. Temporary obstacles means you're getting the wrong visualization, and possibly this leads to planning errors because you don't expect things being where they are currently. New elements being added, so the model does not represent a real twin anymore. And major changes in an area results in an outdated model, and very often it means a high effort to align it with reality again, subsequently, or again, half the sentence missing, or you need to find other ways to kind of point out that this part of the model isn't current anymore. So what is our solution? You can basically use document links to folders or databases dynamically, and that way integrate the up-to-date documents not into UPV itself, but as a link to your external source, which is hopefully always kept up to date. Okay, that's the wrong sentence here again. Wonderful. When you add temporary objects, so temporary obstacles can be displayed and removed easily in your model with UPV. This can be done, for example, through sketching. If it's permanently, you can also do exports and reprocess it, recalculate it into the model. So you always have the correct representation of the as-is status, and as opposed to the planned as-built status. You can use sketching for updates. So if you added new lines, for example, from operations or maintenance, some bypass, as I mentioned before, you can model that easily with UPV sketching, save it away, and send it to your EPCs to subsequently add it to their model. And that way you're also keeping the 3D model and the authoring system up to date. So whenever they generate a new version, you're having that built in. As I mentioned before, you don't have to rescan the whole plant or asset just to replace a single portion. You can actually just replace those parts of a laser scan that have really changed significantly, and keeping the rest from the previous scans by using the laser scan clipping, removing part of the old scan and replacing it with a new one. So in this case, let's actually have a look at the live demo. So first thing is when we're talking about outdated documentation or risking the outdated information. So in UPV, you have the possibility to add links, like we have these links up here. So CA experts or to a line list, which is an Excel document. Outside of UPV, how can you actually utilize this to make dynamic links, for example, to a document management system, or just search your local folder paths or network folder paths? So I've prepared a small file containing links. Let me open that one. So I added here a link to Google, searching for, and now %25 means this is the name of the UPV attribute that it's supposed to add. So it's dynamically taking the value of an attribute of the selected object and putting it into the link when I click on it. And a bit more complicated, I did the same thing here for the local Windows search, giving it a start path to work from. So it's actually a lot easier than it looks like here. So we're giving the link a nice display name, giving it a color, closing it. So if I name this file links.xlsx, it's automatically loaded on model startup, placed in the data folder. And if it's called differently, it will not be considered automatically, but it can be loaded manually like I'm doing now. So I will replace the existing links. And now when I click on D240, you see how I have two different links it found now. So let's take the simple one, the Google search, which will open up in a separate window. Wonderful. Give me the result. It's looking for D240. Let me actually click on E240 and run the same link, and it will search for E240 on Google. And yes, we're actually looking for a column here, not for a Mercedes-Benz, but oh well, that's Google. So what is this other link doing? Basically the same thing. So when I click on dynamic Windows search here, it will search in the path I've given it for documents containing D240. So here I see, okay, that's under equipment documentation. You're giving me the full folder path, so I can just open the document. Or if I click on a valve, say, okay, give me dynamic Windows search, and it's still giving me D240 as a result, which is wonderful. I wasn't looking for that one. Okay, so when I click on this one, it's giving me VG003. So if I look in the name here, yes, it's VG3003. When I open that one, it's under valve data sheets. So it's giving me the data sheet for this valve. So NPD is 6 inches by 6 inches. Okay, so what would it actually give me if I picked this one down here? Dynamic Windows search, and it found a document with the name of the valve. And here we see, okay, it's a 2 inch by 2 inch NPD, so it's a different document here. And also give me the correct name. How can we utilize this? If you have a document management system that allows you to send API calls, you can use these API calls to directly access your original document without having to process it, for example, the document adapter into UPV. It has many advantages. The only disadvantage is if you don't have the document inside your UPV model, is if you want to work with it offline, then obviously those links won't work offline. But you can still do a combination of both. But what about temporary obstacles? Well, let me move through our laser scan model here. And let me actually show you this part here. Let me turn on our panoramic image. So initially you see we had an obstacle here, which was an IBC container. And that one was removed from the model. But let's say this IBC container was placed again in the same spot. So in here, we actually get the feeling that with a forklift, we could pass easily. Well, we probably wouldn't pass the door here, but let's pretend we would. and I want to show that there's something standing in the way as a temporary obstacle. I can go ahead, create a sketch, and in this case, place an object here, move it a bit to position, and then trying to actually match the scale of the IBC container, which is interestingly almost the size of this box, almost perfect match. And now I can add an attribute and say, okay, this is IBC underbar container 01. Maybe give it a different color to see, okay, we've got an obstacle here. Or for example, we can say, okay, we can move around this IBC and we can plan some works going through here. But unfortunately, we have a scaffolding placed right here. So we can't actually pass through there. So let me place it a bit further here. And say, okay, this is where the scaffolding is currently located. So this passage has been closed too. Again, this is also part of the as-is management. So we can simulate and visualize things that are actually happening out on site dynamically with a few clicks, instead of having to run through an engineering process, an expensive authoring system, or similar. But there's also other ways of visualization. So let me actually go to the photos from the boiler room. We can also take pictures and use them to visualize what the situation is. So in this case, I actually did an overlay. If I unlock the camera, here you can actually see only those two heaters and approximately what the room looks like. But other than that, it's an empty room. So I could think, okay, well, there's plenty of space to operate. But if I activate the picture again, you can actually see that we have some pressure sustainment vessel here, that we have some, I think it should be an emergency blanket back here, and that behind it there's some piping that is still not modeled, but it's there. But just taking a simple picture and overlaying it with a 3D model, I get a totally different impression and come closer to managing the situation as it is. And if I'm planning to to conduct some works here, I can easily see, okay, stop, there's a few more details I have to consider here. But what about adding new elements in construction? Let me actually switch to different model here. So what you see here is good. As an enhanced laser scan, I can actually turn off the sketching objects. So you see it's really a plain laser scan. And to add to the visualization here, I've been using sketching objects and picture overlays. So in this case, let me look at the northern face. So this is a photo image of what it looks like here in reality, and this is what the model looks like. So you can already tell, I can see that here is not just empty space, but there's some trees and bushes, and you can also see that the ladder here is a different type in reality than in the model. That's the details you can see by comparing just images, photos that were mapped over the model. But let's go to our pressure sustainment room and plan a new pipeline. So I'll just use this hole in the wall and place some type of valve station with a bypass right here. And again, I will be using sketching here, going back to objects, and I'll just place the pipe somewhere here at the wall. Go to attributes and reduce it from 8 inches to 4 inches. Move it a bit into the wall and, well, move, not scale. Okay, here we go. And placing it in the hole here. And now, let me select it and go here. Hold on. Undo. Shorten it a bit. Move it over here. Okay, but now it doesn't fit my hole anymore. No problem. In sketching, I can actually go to move and adapt it here and go to the other side of the wall and basically do my piping through the tunnel here, actually hallway. Move this one again close to the wall, and you see the elbow is following my sketch. Go back to scaling and pull it now all the way down to the floor. Let's say it's coming out of the floor, and now I want to add a bypass somewhere here and going over here. Okay, we're coming in conflict with the elbow, so let's move it over a bit, maybe this a bit lower. Wrong arrow. And now let's place some valves in here, maybe 2 different ones, and adapt the hand wheels so that we can actually access it. So with a few clicks, I've actually created a valve station here. Still don't like the looks of it, so I can move things a bit, adapt it quickly, and save it to the model. So now there's 2 ways. I can either load the sketch if it's, for example, a conceptual design, but if it's already been built, then I can use this and save it away. There's 2 options here again. If I go to files, to my sketch 2 now, go to save, I can save it as a DGN file or as a UPVC file. I can even go to attributes and give names to the objects, give them attributes like pipeline or similar. So let's actually select them, these here, and say, okay, pipeline is PL123. So now I have added this attribute to these objects, and when I export it to a UPVC file, and next time I generate the model, for example, overnight, I take this UPVC into the calculation process, then this will become a fixed part, a static part of the model. And again, we have an updated model without any additional high-end authoring tools. What other effect is there? If we save it away as a DGN file, you can send this easily to your EPCs as an owner operator and say, okay, we have added this to our model, but please use this as a reference. Basically, put a reference into your authoring system, remodel this with the proper pipe class, give us the isometrics and things to pull the documentation straight on both ends. But no need to draw any type of handwritten drawings or similar to give it to the contractor or EPC, but you can just give away your UPV file and say, okay, here's the DGN, take this as a reference, and basically rebuild it quickly in the authoring system before you generate the next model snapshot. And last but not least, what if we have major changes in a limited area? So let's say this object here, this pressure sustainment vessel, has actually been replaced by a new one. So first of all, since we used laser scan clipping, I could just go ahead and turn this object off and place a sketching object above it as a replacement. Or I could say, okay, I don't want to rescan the whole building, but it's actually no hassle to place a laser scanner here and make 1 or 2 scans from this position and this position perhaps, and just redo this part of the building. So how would we then replace this? Well, easily by placing a box, scaling the box to the size that I need. So I'll do it very roughly. And for the laser scan clipping mode, you just pick update. So when you reprocess your model, you just add the UPVC from the new laser scan and set the clipping plugin to use an update with the new model on this position. So what it would do, it would remove everything from the laser scan inside this box. And on the new laser scan, it will remove everything outside of this box, and basically like Lego, take this box from the new scan and place it right here. And that way saving us a lot of additional costs and also time and effort for updating the scan. So these have been a few examples how we can actually utilize UPV to update things to the as is status. And I don't want to leave out the PNIDs. So let me actually leave the sketch here and reset my view and go ahead to, let's say, this PNID. So changing the PNID I can also do through PNID sketching by saying, okay, we've added a bypass here and we want to have it in our documentation. Where's my valves here? Place a valve here and perhaps change the color of the sketch to now red is actually for new ones. As built would probably be not really yellowish, so I used to use this bright brown for actually showing as built changes or additions. And this can again be saved in the file and also sent, for example, with a markup to your APCs to update the authoring system source files accordingly. But on site, the maintenance department, the operations department can just draw in changes easily and they will be available instantly without having to run through the whole engineering documentation process.